try to do this quickly because it's not so different. So now we have three things. We've got one trace I3 plus plus one trace I10. Neither plus nor minus, or minus.
Minus sign.
Minus one. Yeah, thank you. And then minus or plus. That's trace I0 plus. Right? Yeah. Okay, so that's good. And now when you restrict, okay, first of all, when you restrict the induced guy, you get 0 on the non-identity component, okay? Because the delta is flipping the entries in the matrix, so to speak. So you take the trace of a non-anti-diagonal matrix, you get 0. So that thing disappears. But we're left with 1 trace delta, or so we think, 3 plus, and is this one? The other trace I0 plus delta. Okay, so the twisted trace looks like that. Now, we could spend some time thinking about what's going on over here. Do that. But before we do that, we want to do that. The fact that this is a +1 is bad, right? So before we had a -1 over here with the relative discrete series. And that's what gave us the subtraction we needed for the trivial representation of the endoscopic group. Okay, but here we have a +1 sign. And so when we follow the obvious thing to do, at the end of the day, we don't get the trivial representation over here as we wish to. We get, let's see, we get the full principal series plus the relative discrete series. And well, that's stable, but that's the wrong answer. Okay. So what's wrong? What's wrong is that when we use this transfer business, we're using this theorem over here. Right? Now, that theorem, it's using the Whittaker normalization, okay, the thing I mentioned before. When you're choosing some sort of preferred extension to the extended group, two choices, we're using one that's normalized by a choice of Whittaker data. Okay? And for GL3, you can prove that that is the negative of the one you get from the Atlas parameterization. Okay, so that's what saves us. I don't really know how to write that. Maybe I'll just make something up. So this one is okay. It turns out that the Whittaker normalization and the Atlas normalization for principal series always coincide to prove them. So this is the same. But we've got to put a minus sign here, plus -1. And instead of writing I0 plus, I'll put I0 in WH, Whittaker, something like that. Great. Okay? And now, when you use this theorem, you're using Whittaker normalization, and it follows the same way. And you end up with this over here, which is what you would expect. Okay, so it's a source of great headache to be in Nicola. We'd like to be able to say when the Whittaker normalization coincides with the Atlas normalization, and not have to worry about things case by case. That's something we're going to get to. Let me just, any questions about GL3? So that's the one you think. Otherwise, not so different.
So you checked explicitly that these two normalizations really do differ?
Yeah, you can check that explicitly. Yeah.
And you think that's a general fact, or that, or
They don't know, so for GL2, they're the same.
Right.
For GL3, this guy differs. This relative discrete series, right? So yeah, there's some complicated one. There's some formula that tells you when they're the same, when they're not. We have to get to the same one.
I think that the difference would be given by a -1 to some difference of length.
Yeah, so
there's different.
yes, there's some kind of length that we're trying to look at. In fact, your paper with Alas and Miguel has some lengths that come from endoscopy that might work. So we're looking into that right now. Yeah, there's got to be something theoretically satisfying that tells you.
Two kind of length and the difference between.
That's right. Yeah, difference. Yeah, just like you had the difference of lengths earlier, you have to find some kind of alternative definition of length that will help us with that. Okay, let's just GL5 quickly. Maybe like it's bigger. Figure out how to make it bigger. No. Shift Control plus. Yep. There you go. One more.
Back one.
Back one. Shift Control. Shift Control minus there. Is that good? Yeah. Okay. So let's see. We've got GL5. And delta is distinguished evolution as before, and H is SP4R in this case. And if we do print extended character formula, then what we get is something that looks like this, where I leave number 45 is the, may as well do this, it shouldn't take very long. So just print it again, G equals GL5R. And delta distinguished evolution. Sorry? Oh, right, colon. Okay, and as I said, H. Come on. 4R. Great. Okay. Print extended character formula. G delta. Thinking. There it is. Okay. So this data here. I converted into letters on the other screen. Let's just take a moment. We can get rid of all these zero guys, right? Because when you go from the extended group to the twisted one, they all disappear. So we can get rid of those. What else can we do? If we have a +1 in the second entry, then this stays as it is. If we have a -1, do we have a -1 here? No. So everything stays as is, except just remove all the guys that are induced, that have 0 in the second entry. And then we should get something that looks like what was on the screen before. Oh yeah, and then 45, I believe, is trivial. Let's check that too. Print log. What's the right thing to do? Print. Is there any way to make this look better? You can make it smaller. It's about the only thing I can do.
No, but just scroll up.
Okay, scroll up to
Scroll up
see
and
what it
see,
says.
yeah.
Yeah, it says
45.
element number 45. Okay. Yeah, we know that.
Okay.
Okay, so let's go back to this. So this thing, all this stuff, what is this stuff? This expresses the twisted character of the normalized trivial representation, like this. Did I do some sign changes? Oh, there must be a 3 minus in there somehow.
So no, you change all your minuses to pluses. From going from the first line to the second.
Yeah, I realize that, but I didn't see any minus signs. So this is,
Yeah, there's.
oh yeah, there's a 3 plus with a minus there. But, okay, I don't know why.
Oh.
Yeah, it's weird, I don't know why.
3 plus with a minus. Oh.
Mistake. Or so it would seem. Yeah, it's probably something wrong. Something they don't want to post this. Anyways, up to pluses and minuses.
So
that
this
just
print
happens.
extended character formula
Yeah.
command, when you're getting a minus representation, it puts an S in the coefficient. It doesn't put a -1. I mean, this, 3-1 always indicates the plus.
Yes.
But 3-1 never appears. If the representation 3-1 appears, that's indicated with an S term in the multiplicity.
How about if I do extended composition series? Then do I get a -1 in the second entry?
No, I think it's the same thing. but
I've seen
number-
-1s in the second entry.
Oh, it can happen, but.
Yeah.
My,
It definitely can happen.
I thought I just looked at some example that I mean, the extended character formulas certainly can have S terms in the multiplicity, and I don't know what that means except to change the.
Anyways, this is fairly clearly incorrect. So there's some sign changes there, which actually makes me feel strangely better about it, because there should be differences between the Whittaker normalization and the Atlas normalization in this case as well. Let me just indicate, so this is stuff with the tori. Let me show you, the character formula for the trivial of H looks like this. Let's look at that for a moment, and then see how these two things might match up. So print character. Trivial. This at least should be right if I spell trivial correctly. Okay. Print character formula. So I have, let's see. Is there a way of seeing this with the indices? 'Cause that's what.
Well, there's just sort of obviously 10 down to 0.
The X equals.
That uniquely determine the
index.
index?
Yeah.
Okay, prints. Let's have a look at that. Prints. Wrong. Yeah, that's right. Except for the principal series, they're all determined by the KGBL. So that gives us a way of keeping track of what's what here. All right. So this information over here is given over here. So I've blocked off certain parts. This part over here corresponds to the tempered representations and corresponds to exactly one pseudo packet for SP4. Okay? So that one pseudo packet for SP4 is something like this on the left-hand side, and therefore that should correspond to some irreducible representation on the extended group of GL5. Okay? And all the other things that I've blocked off here, now keep in mind that the plus signs and minus signs are probably wrong, okay? But at least the representations are blocked off together the correct way. Then there's this, and this. So 1, 2, 3, 4. No, 1, 2, 3, 4, 5. There should be 5 things. Each one is a pseudo packet for SP4. And they correspond, is that right? So 1, 2, 3, 6. Did I miss something? Yeah, 6. 1, 2, 3, 4, 5, 6. The bottom one here is the principal series for both of them. The top one is the tempered guide for GL5, and that's the tempered pseudo packet for SP4. And then there are all these intermediate ones which match pseudo packets for SP4 in this case. So sometimes the packets contain 2 representations, sometimes they contain 1 representation. That depends entirely on which torus you end up in this diagram. Okay, so I think that's enough. That's all I
Well,
want to say.
so what's the conclusion from this case? Can you make it work?
No, I can't make it work because the
Because the
signs
same
are
issues,
off.
yeah.
Okay, but yes, if the signs were correct, if they were all the Whittaker guys, I'm certain of these ones. There's one other thing I did. So I've been doing the trivial representation the whole time. You can also look at the example of ABB, which is singular, but more interesting. So it has a nice picture of all this stuff, and you'll get the trivial representation. You get some spontaneous A packet that you did not see on this way. Okay, thanks.